Hi again, this is Miss Brown, and we've already talked about scaling to create equivalent ratios. You already know what that is. We're basically finding multiplicative connections between numbers. Let's practice scaling to create equivalent ratios. So, our directions are to use scaling to create equivalent ratios. Problem number one, we have the ratio or fraction 5/8 is equal to what number over 32? Again, we want to look for connections between numbers. They can either be horizontal or vertical, making sure you go from what you know to what you don't know. So for hoots and giggles, I'm going to see if I can make a vertical connection going from this 8 to this 5. Well, guys, there is a connection, and I'm not going to tell you what it is, but most of my seventh grade students wouldn't easily be able to find a connection between those numbers. So let's see if we can find an easier connection. Instead of going vertical, let's try horizontal. Is there an easy way I can go from this 8 to this 32, either multiplying or dividing? And our answer is yes, there is. I can take 8 and multiply it by 4, and that gives me 32. So what I've done on the bottom in the denominators, I'm going to do the same thing to the top in the numerators. And I'm going to go in the same direction, going from what I know, 5, to what I don't know, which is what goes in that box. And since I multiplied by 4 on the bottom, I'm going to multiply by 4 on the top. And what goes in that box? The number 20. So 5/8 is equivalent to 20 32nds. All right, let's go to number 2. And you'll find that our problems get progressively harder, mainly because I stop using whole numbers and start going into decimals and fractions. Part of our seventh grade curriculum is that we have to have a good command, not with just whole numbers, but also with working with decimals and fractions. So anyway, I'm looking for a connection between numbers, vertically or horizontally. Well, I'm going to look at this 8 and think, is there an easy multiplicative relationship going from 8 to 11? And guys, it does exist, but most seventh graders wouldn't be able to easily tell you how to get from 8 to 11. So maybe that's not the best relationship to look for. Well, let's look vertically. Let's talk about going from this 8 to this 2. And let me tell you why I'm going from 8 to the 2 and not 2 from the 8. I know already that I'm going to have to do the same thing on the other side. And so on the other side, I want to go from what I know, which is the 11, to what I do not know, which is what goes in that box. So this is the direction I need to go in. I need to go from the bottom to the top. Anyway, returning from the 8 to the 2, how do I go from 8 to 2, either multiplying or dividing? If you said I take 8 and divide it by 4, and that gives me 2, you would be correct. So that's the same thing I'm going to do on the other side. I'm going to take 11 and divide it by 4. Now here's where some of my kids start going like, oh, Miss Brown, I don't know what to do. Well, let's talk about that. 11 divided by 4, we can write that in different ways. We could write that as an improper fraction, 11 fourths. Yes, 11 divided by 4 is just 11 fourths. We could also take that and turn it into a mixed number. So let's do some division and figure out how many times can 4 go into 11. And I put 11 on the inside of the box because it is the numerator, and 4 on the outside of the box because it is the denominator. Well, 4 can go into 11 2 times. 2 times 4 is 8. Subtract out, that gives me 3. So I have remaining 3 out of the original 4 I started out with. So 11/4 and 2 3/4 are the same thing. Okay, that's not the only way that I could represent that. Those of you who are relatively good with fractions, you'll know that the fraction 3/4 is equivalent to 0.75. So I could also write that as 2.75. So you might be thinking right now, well, Miss Brown, if we have all these different answers, which one is correct? They all are. So unless I or your directions specify how to represent your answer, I would accept any of these that I just highlighted yellow: 11/4, 2 3/4, and 2.75. I need you all to make sure that when you're giving me answers as fractions, that you're representing them in simplest form. So 11/4 would be okay for me, but 22/8 would not be okay. So just make sure you're putting things in simplest form. All right, let's move ahead to number 3. Number 3, if we have $3.75, we want to know how many oranges we can get, represented by my box. If we know that we can get 4 oranges for $1.25. Well, again, I'm looking for connections between numbers, either vertically or horizontally, and also I'm going from what I know to what I don't know. So I could try to see if I can get a vertical connection going from that 1.25 to the 4. Um, it does exist, but most seventh graders wouldn't be able to tell you. However, probably an easier connection would be going in this direction. This 1.25 to 3.75. And you may be wondering, why am I going from right to left instead of left to right? Well, remember, I want to go from what I know to what I don't know. And on the bottom, in the denominators, I know 4, and I'm trying to figure out what goes in that box. So I have to go from right to left. So going back up to finding a connection between the 1.25 and 3.75. Well, I want you to think about this. You probably already know, but let's pretend that I had $1.25. So I have a dollar bill and a quarter, right? So $1.25. Well, let's pretend maybe my friend also has a dollar bill in their pocket and a quarter. So how much would I and my friend have together? We would have $2.50, right? Well, let's pretend that a third friend comes up to me, and that friend just happens to have also a dollar bill and a quarter in their pocket. Well, how much would we have all together, right? That'd be $3.75. So, how many groups of $1.25 does it take to get to $3.75? It takes 3 groups. That is why 1.25 multiplied by 3 gives me 3.75. So that same thing of multiplying by 3 on the top is what I'm going to do on the bottom. So 4 times 3 is 12. So to answer our question, I can get 12 oranges if I have $3.75. Alrighty, let's go for our last example. And in our last example, If I can read, or if I take 1/5 of an hour to read 3 pages, then in 3/5 of an hour, how many pages can I read? Again, we're looking for that multiplicative relationship between numbers. So I want you to think about this. Is there an easy way to go from 1/5 to 3/5? And remember, we're not adding, we're multiplying. Well, I want you to think about this. If I have, let's say I have a cake, and on the first day, I eat one slice out of 5. 1, 2, 3, 4, 5. Yeah. Let's say on the second day, same cake, I eat one more slice out of 5. So I'm coloring in the slice that I'm eating. Okay? And let's say on that third day, same cake, I'm eating yet one more slice out of 5. Well, if I put all of that together, what have I eaten on those 3 days? Okay. Remember, I ate the first slice the first day, the second slice the second day, the third slice the third day. So eating 1/5 of a cake each day for 3 days means that I've eaten 3/5 of a cake. So going back up to hours, what's my connection between 1/5 and 3/5? If I take 1/5 and I multiply it by 3, that gives me 3/5. So that's the same thing I'm going to do on the bottom. I'm going to take 3, multiply it by 3, and that tells me that I can read 9 pages in 3/5 of an hour. All right, good luck with your work.